Hello everyone, we are Team Gladiators presenting our solution for problem statement number 25067 Proposal for Design and Development of Application or Heavy Metal Pollution Indices published by Ministry of Jal Shakti for Smart India Hackathon 2025. In various parts of India, the groundwater is still contaminated with heavy toxic metals like arsenic, lead, cadmium and mercury. Even small amount of heavy metal cause serious health issues like cancer, kidney failure and bone damage. Nowadays, scientists use HMPI value, heavy metal pollution indices, which are mathematical formulas to measure how polluted the water is. The current problem in process of measurement is that the whole process is manual, time-consuming, error-prone, and inconsistent in nature. For this, we need an automated, accurate, and user-friendly tool that should be capable of performing following tasks. The first one is computing HMPI value instantly based on data set of water concentration. The second one is integrating groundwater data with geocoordinates. The third one is classification of water as safe, unsafe, or critical. The fourth one is providing decision-ready outputs for scientists, policymakers, and health departments. The fifth one is minimizing manual effort or human error. And for this, we have made our project AQUASAFE. So let's move towards the technical approach and demo of our project AQUASAFE.
So here's the technical aspect and the proof of solution of our project AQUASAFE. So starting with the technologies which we'll use to develop this project further, first we have to get the lab results, the GPS-enabled devices for geocoordinates. The programming languages which we'll use to develop this application will be Python, JavaScript, React, Kotlin, Jetpack Compose, and the framework and libraries will use as LangChain, TensorFlow, Scikit-learn, and Pandas, NumPy. The cloud services which will use the AWS or GCP, and for the AML part for the prediction of the respectors, the LLM, LangChain, and Google Gen AI SDK, Pandas agent, and custom ML models. And for the visualization, we will use the Leaflet.js, Grafana, Prometheus. For the backend APIs, we will use the Django or Flask. For the database, we can use the PostgreSQL or the MongoDB. So here is the technologies which we use. So moving towards the flow of solution. So how our project AquaSafe will really work? Like starting from here, first the user will start the application, then it will collect the lab data by uploading it, which will consist of the heavy metal concentration of the lab samples and the geolocations, and then it will be uploaded to the app. Then from the backend of the HMPI formulas, the HMPI calculation is done. The calculated HMPI will be displayed and it will categorize the water quality as safe, marginal, and unsafe on the dashboard. And also after the HMPI calculation, the user that are policymakers, scientists, or researchers can download and generate the reports. And also they can get the AI insights like policy formation for the policymakers. They can get the customized policy suggestions for the customized location, and also the visualization on the dashboard will be done of for the data uploaded. So it will make overall application very easy to navigate and easy to understand. So here's how our project AquaSafe will work. So now moving towards the demo of our project. So here is a demo of our prototype AquaSafe. So here first we have to register ourselves, like gmail.com. Our guide password we will set it. Okay, and the create account. Yeah. So here we have to set the we have to sign in. Now sign in. It will redirect us to the main page of our portal AquaSafe. So first we have to first step is to upload the water sample report here, which come from the lab. Uh, so here we have uploaded this file process. Now it shows the water safety status. It calculated the HMPI 14.1. So when we click into the open detail analysis, it will give us the detailed analysis of the report which we have uploaded. It shows the overall HMPI that is safe 14.1, which is below the threshold value. Safe quality is 99.3%, unsafe is 0.7%. It also shows the individual heavy metals which are present in that water sample. That is arsenic 10 microgram per liter, followed by lead, mercury, cadmium, chromium, iron, and furthermore. And also, user can check the heavy metal concentration in respect of BIS limits. That is the threshold limit set by the BIS. You can check with the bar graph. Here also, we are categorizing the water samples in three different cases: safe samples, unsafe, and critical samples. And also followed by the integration of groundwater report with the geo coordinates. Here we are using the map where you can see the regions which are contaminated, which are safe, moderate, and unsafe, and critical. You can check here by zoom in and zoom out. And now next, user can also check the region-wise contamination data like Maharashtra, Delhi, Karnataka with the different heavy metals concentration with the pollutant and status like warning critical. And also you can check the historical data comparison with the current HMPA values with the past years and the past months. Here the past years and here are the past months comparison with the current data. And also the our portal can predict the HMPI forecast, like what can be the upcoming HMPI in the next month or next week with the using of AI and ML. And also we are giving the alerts and notification to the higher authorities and supervisors for the taking the mitigate actions. And also here you can find the finding some of these like overall improvement, critical hotspots. So we have covered all the aspects. And now here one more thing, like the user can download the like the report and generate the PDF report, and it has been downloaded here. And you can check the water quality analysis report. You can check the key metrics, sample distribution chart, metal concentration, heavy metal concentration conclusion. So the lab researchers and scientists can get the PDF reports as well. And for the policymakers, we are giving the policy recommendation as per the water sample which we have uploaded. It gives the critical prevention measures, sampling procedure enhancement, and also the regulatory compliance step. So the uh, lab researchers, the scientists, and policymakers can easily use it. And also one more thing which we have added here, like the lab researchers and scientists who do not want to go through all the part of this portal, they can easily ask here about anything like so arsenic hotspot near Nasik in 2019. So if they, the query is processing, the AI assistant is giving the result as according to the data set and the extracted data. So the portal is working fine, and we have covered all the aspect given by the Ministry of Jal Shakti, like the user-friendly app, role-based access, login and registering, automated computation of HMPI, and the integration of groundwater heavy metal uh, with the geo coordinates and the categorization of the water samples and the reduction of manual efforts and error-free portal. Like so, it is covered totally and it is working fine. And also, we have integrated one more thing as a unique feature, like we are predicting the upcoming HMPI forecast and the contamination risk factors with the use of AI and ML. So it will be discussed further, and we have covered all the given aspect by the Minister of Jal Shakti. And if we make it to the grand finale of the SIH 2025, so we will make more like effective with the collaboration of Minister of Jal Shakti. It will be more refined and accurate after we work more on this. So let's take the demo of the prediction of HMPI forecast.
Here comes the AIML part. Once the water quality dataset is uploaded, our ML model quickly identifies the anomalies in the dataset and also classifies the location based on the predicted risk level. You can see here, our ML model has predicted the risk levels. Our project is also integrated with AI Assistant, in which user can ask queries related to the dataset, and also it suggests policies regarding the dataset. For example, in this query box, we have asked suggest some policies which will be beneficial for this dataset. Our AI assistant has answered these query, and it has also told the policies with its benefits. User can ask queries related to dataset like, for example, tell me the status of water at Maloya. It's in dataset. The status of water at Maloya is safe. Thus, it gives instant, reliable answer to the user query and also helps in suggesting the policies. Thank you.